Having received the ire of the community for its product stack, Intel today sets forth in an attempt to validate the challenged existence of its X299 platform, new Skylake X, and new Kaby Lake X CPUs. We're starting with the 10-core, 20-thread Core i9-7900X, which is Intel's new $1,000 CPU that takes place of the once $1,700 i7-6950X 10-core CPU. This is a significant price drop over time, but Intel is no longer competing with only itself. Skylake X's precipitous launch lands between Ryzen and Threadripper, due out in early August. And today we're looking at game streaming, VR benchmarks, Premiere, Blender, and other benchmarks of the new i9-7900X. Before that, this is brought to you by Corsair's Vengeance RGB memory, which uses binned ICs for higher overclocks and uses the SM bus to write its colors rather than relying on cables. Learn more at the link in the description below. Let's start by revisiting some of our earlier 7900X discussions from when we delidded the CPU at Computex. First of all, that RFID chip in the corner, we got some clarification on that. That chip is actually not capable of storing data because its SM bus is not physically connected. So it could do something if it were connected, but on the HEDT CPUs, it is not. And the reason that RFID chip is there at all on the package is because Intel is using the same package for its server versions of these CPUs as it is for the HEDT versions of these CPUs, and that just means that it's kind of a leftover because, again, same package for both types of products, but it's not physically connected. So that's good in some ways, though it could potentially provide functionality. It could also provide things like backdoors, and we don't have to worry about that at all because you just can't read or write to or from the RFID chip on the package. But that also bleeds into the next point, which is the really interesting substrate design of the 7900X. When we delidded the CPU, we showed that the CPU almost resembles an LGA 11.5X substrate atop the 2066 substrate. Intel couldn't answer why the design is like this, citing, quote, manufacturing reasons, which is the same reason they cite really for anything like use of thermal paste rather than solder. And our present hypothesis, having not seen the server CPUs, is that the server CPUs might use more of the lower substrate and ditch the upper substrate part, the protrusion, but Intel is keeping the same package for everything. We're really not sure if there's a legitimate technical reason for this approach at this time, or if it's more of a cost-saving thing, as Intel just wouldn't tell us. As for the CPUs themselves, our current understanding is that the 14-core, 16-core, and 18-core CPUs will be based on the same silicon from a 20-core CPU, with some of them disabled or removed. We're not sure 100% about the lower end SKUs like the 7900X, which is a 10-core part, but we do know some about the die size because of that delidding process earlier. So the 7900X measures in at roughly 334 millimeters squared, some rounding involved. And for reference, the previous generation 10-core to 24-core parts ranged from 246 millimeters squared up to 456 millimeters squared in the enterprise division respectively. But anyway, the substrate design is genuinely interesting. Hopefully we'll learn more one day at some point. We do know it uses thermal paste, probably Dow Corning, and no solder for this one, even though it is a larger die. We'll look into the thermals in a completely separate video because there's frankly enough for today. We're not gonna really spend time going over a brochure with specs on it. That's not really the point of these. If you want that, you can check the table on the website. The 7900X is under test today and is used with the Asus Prime Deluxe X299 motherboard. For full testing methodology, again, check the article linked in the description below. We're focusing on game streaming benchmarks, including single and dual stream outputs simultaneously, VR benchmarks to validate Intel's own marketing language, as we figure a few others will bother with VR benchmarks, and then dive into the production workloads. We're saving some stuff for later, like thermals and power, because we're up against deadlines. Overclocking will also be discussed in more depth in the article, since overclocking results were still rolling in as we filmed this video. Starting with streaming benchmarks, this is the first time we've ever done this type of benchmarking for actual game streaming via OBS. And so it's exciting, but there's also still a lot to develop methodologically and a lot to develop in presentation method. There's a ton of data. It's not necessarily easy to figure out how to display it. So there's more to come later. But for now, we have a baseline. We're using two main tests. One is exporting to a single stream, just Twitch via OBS at 6 megabits per second, 1080p, 60 FPS with H.264 encoding. And then second, we're streaming to both Twitch and YouTube simultaneously. So you've got dual stream output from the same box that's playing the game. And that's done with the same settings for Twitch, but with 10 megabits per second for YouTube rather than 6 because it supports a higher bitrate. And finally, we do have an extra FPS baseline benchmark without streaming and another benchmark with NV encoder, or the GPU accelerated encoding rather than CPU, so we can get a baseline for everything else and all the other main options in the system. In addition to the FPS numbers, we're using login to measure what we're calling delay frames and drop frames, another term that we use for VR benchmarking. For these, we've got usual frame time and frame rate metrics for the host system's game output to the player, and then the drop frames and delay frames are used for the viewers so that you get an understanding of what the actual quality is going out. Delay frames happen when the CPU can't complete the encode in time to hit its roughly 16.67 millisecond window before the next refresh. And so this tends to be indicative of more of a GPU limitation. We can run into these with high-end CPUs if we are running into a GPU limit because the CPU can keep up fully. A drop frame, however, is indicative of, in this scenario, a CPU encoding issue where the CPU is actually just skipping the frame or dropping it entirely, so you end up with sort of almost micro stutter in the absolute worst case scenario if you're dropping 50% or more of your frames. And that is just because the CPU is getting overwhelmed, which will certainly happen at some point as you pile on more simultaneous encoding streams because the CPU can't keep up with the workload. And we'll talk about more of this going through it, but we're starting with the R7-1800X and the i9-7900X, of course, both in stock configuration, both with 3200 megahertz memory. And for full testing methods, again, on the new benchmark, check the article below. It'll answer all the stuff in more detail. Let's start with a single stream first, as it's the most common use case. Streaming to Twitch only, we saw no drop frames on the 7900X and no drop frames on the 1800X. Both are adequate performers with delay frames not noteworthy or perceptibly different between the two. Here's a look at the differences in terms of frame rate. The i9-7900X posts an in-game frame rate of 104 FPS average, 79 FPS 1% lows, and 31 FPS 0.1% lows, with the R7-1800X sustaining 96 FPS average, 68 FPS 1% low, and 27 FPS 0.1% lows. Let's put a chart on the screen below this one. This chart, now that you can see both of them, shows the performance when there's no streaming at all, with just the game being tested standalone in its same windowed configuration, because again, it's a stream benchmark and we're doing A/B testing. We're going from 112 FPS average to 104 on the i9-7900X when compared to no streaming, and with the 1800X, we're going from 109 FPS average to 96 FPS with the Twitch stream going. The frame time performance is significantly improved when we stop streaming, as you can see in the low numbers, and justifies why you would still want a separate capture machine for really competitive gaming or games where frame time variability can affect your ability to play competitively. Moving on now to our next chart, we're looking at streaming performance when going to both Twitch and YouTube simultaneously. There's a lot of data to process here, so we're just going to start with the chart of Twitch performance when streaming to both services and then look at YouTube as well. These tests are meant to illustrate performance when outputting to two destinations, like when the user has an audience on both platforms and is becoming increasingly popular and is traditionally done with a separate capture machine to alleviate load on the gaming machine, so we're going to see if that's still needed here. Here's the chart. Performance to Twitch during this dual stream benchmark posts 0.13% drop frames on the i9-7900X, averaged across multiple test passes of the same duration, which is largely imperceptible to both the viewer and the player. Delay frames are 5.03%, which we think, but we're still learning as this is new testing, is because the CPU is performing well enough to bump into GPU limits. The 1800X has a much harder time with this workload. AMD's 1800X is dropping 54% of its frames to Twitch, which results in something of a slideshow for playback. For comparison, NV encoder is still choppy for about 20% of its playback on the 1080 with the 7900X, even with two NV encoder engines running, so generally speaking, CPU encoding is still going to be preferable when you can get away with it, but that's clearly not always the case. Adding the YouTube chart to the page now, the i9-7900X sticks to well below 1% of total frames dropped, with GPU frame lag still around the same level. AMD sees about 78% of its frames dropped here and struggles with the H.264 profile and dual stream outputs. To make things easier to understand, we're putting the actual stream footage that went to YouTube on the screen now, showing the 7900X next to the 1800X. Again, remember that while this is going on, we're also exporting to Twitch, so there are two encoders going on simultaneously, one for each stream. The extra 4 threads really help Intel in this specific use case, but just for sake of understanding performance, here's a screenshot of utilization on the Ryzen system and the Intel system when under this intense workload. And again, this is H.264 with the encoder set to faster rather than very fast. So you could lower your quality and possibly still sustain it, but it would be a bit rough on the Ryzen CPU. As for FPS, this is what it looks like. The stacks chart shows an average FPS of all three tests. We're down to 75 FPS average on the 1800X, still fine if it weren't for the stream struggling anyway, and 89 FPS average on the 7900X. Now we're faced with the challenge of analyzing what this means. The first big disparity is in frame time. So the average FPS on both AMD and Intel in this very specific test looks just fine when you're streaming really to any of those two scenarios. What doesn't show up in averages is what we see in frame times, 0.1% lows in this case, or we do have a frame time chart as well. And that is the case that the CPUs get over 70 FPS and 0.1% lows in our charts when there is no stream going on, and then they fall below 30 or around 30 when streaming is happening, which is not really the best case scenario, especially if you're trying to stream something like CSGO. That will get you killed. But for a lot of other games, that might be just fine. So it's something where it's going to vary on a game-by-game basis whether that's acceptable to you. Depends on what kind of content you're working with. Anyway, this frame time chart shows the dual streams versus no stream on the i9-7900X, clearly illustrating the improved frame time consistency on the benchmark without the streams running. That's where those 0.1% low numbers are derived. High variability in frame-to-frame latency is what we're seeing here. With all of that detailed, a few notes. The Intel i9-7900X is an impressive CPU for this dual streaming use case scenario, certainly. If you must stream to two sources simultaneously, and if you cannot build a secondary capture machine, then this isn't a bad solution. In fact, a $1,000 CPU, the 7900X, may actually be cheaper than building a dedicated capture machine in addition to the gaming machine. But you still lose performance in frame time. So for people who are ultra competitive, we'd still suggest building a secondary capture machine if you have the space and the budget to do it. If that's absolutely out of the question, then this CPU gets you closer, but still outputting to just one stream is the best middle ground between them. Ryzen does well with single stream performance here and does dominate in the price to performance argument versus the 7900X by quite a lot, particularly considering you could buy an R7-1700 instead of the 1800X, which we would certainly recommend because the 1800X is superfluous. You could overclock the 1700 and get the same performance or better than the 1800X out of box, and that way you could run a cheaper solution than the 7900X, stream your one source, Twitch or YouTube, and really do quite well in the price to performance market. But to be fair to Intel, the 7900X does crush everything in the dual streaming tests so far. So that's not to say R7s couldn't do it, you just really have to lose quality to do so. Both CPUs have their place, just depends on what you're doing. Let's move on to another set of harder benchmarks. This is VR testing. We debuted our VR testing methodology in our R7-1700 versus i7-7700K VR benchmarks, where we noted that the CPUs were imperceptibly different from one another. You would absolutely not be able to confidently tell the difference in a blind test. And if you didn't see our previous VR tests, we'd strongly recommend watching those for a full description of how this procedure works, because it's quite complicated and the most complicated benchmarking we've ever done. Not going to re-explain it all here. But the real reason to reintroduce these benchmarks now is to validate some of Intel's marketing slides that we publicly disagreed with in the initial news announcement about these products. In their slides, Intel would lead you to believe that their existing non-K SKU, still high-end CPUs are insufficient for VR gaming. That's plainly false. In fact, Oculus Rift officially recommends, not requires, recommends an i5 4590 CPU or better. There's no K on there. The HTC Vive recommends the same hardware, and in our own testing, you would do fine with an i7 non-K SKU with really pretty much any game you could throw at VR. So these slides served more of a point to find a way to say, VR, it does VR, it does it really well, rather than actually say that this is the capabilities of each of these products. Intel is cannibalizing their own existing product line to make this one look better, which we don't necessarily agree with. So we benchmarked it to see what the performance would actually look like in an objective VR test, since those really are still quite rare because it's hard to do. And it's kind of interesting results, but maybe not surprising. Now the main point here is going to be to compare the 7700K to the 7900X, seeing as we're really just validating Intel's own slides, but we do have 1700 benchmark numbers as well. If you want the hardware capture from the capture machine, which is extra complexity, check the article. We're going to do just software here. Let's look at Elite Dangerous versus the 7700K, shown in blue. The i7-7700K technically outperforms the 7900K here, and that should be somewhat expected. It's got a clock advantage, which is often more beneficial than a thread advantage, and generally speaking, VR games don't really have the best multi-threaded programming right now. That said, the difference is again imperceptible. The two CPUs are effectively identical in actual perceived performance, but if you are buying for VR gaming and nothing else, this shows that clearly the 7900X is not only unnecessary VR, but technically closer to the 11 to 13 millisecond frame time cutoff point before entering into drop frame or warp miss territory. The 7700K, meanwhile, stays closer to 9 millisecond average frame times. Again, with a 90 Hz interval, we need to hit that 11 to 13 millisecond frame time target prior to the runtime kicking in and applying warps and finalizing animation. And now, just for a quick showcase, here's the 7900X and the R7-1700 in stock configuration. The 7900X does indeed outperform the R7-1700, which was also outperformed by the 7700K, but between all three of these, none of them are really running past the runtime in any meaningfully different way. In fact, we've got a better way to display this data. So here's a bar chart for Elite Dangerous with average FPS. In terms of delivered frames to the HMD, we're seeing a perfect 90 Hz on all headsets. A simple extrapolation of unconstrained frames pegs the i9-7900X below the 7700K stock CPU, but the difference is again not noticeable. Our dropped frames are still just 9 out of 5,400 intervals. So that's really not bad. You are never going to see 9 out of 5,400, whatever percentage that may be in this type of scenario. AMD's 1700 also does well here. Really, all of these CPUs are fine, and so there's no need for a $1,000 7900X to do this VR workload, though Intel tells us that it wasn't just marketing for VR gaming, it was also for VR content creation, except that's not what the slide said, so that's not what we're benchmarking right now. Here's a look at Elite Dangerous average frame times in milliseconds. The i9-7900X runs an average frame time of 9.35 milliseconds, plus or minus 0.25, as there's some variance in these tests. That's below the 7700K, for which our stock and OC numbers are effectively identical and are within our error bars and just ahead of the 1700 OC. With Dirt Rally now, we see a similar experience. The i9-7900X is technically slower in frame times in this interval plot than the 7700K, both stock, though the two are realistically, again, imperceptibly different. The i9-7900X would be a monumental waste of money for VR gaming, considering that Intel's own i7-7700K is still the best performer we've seen or tested for virtual reality. By this interval plot and frame time chart, the 7900X is again technically better than the R7-1700, but again, it's not noticeable, and the 7700K is still technically better than both at this particular workload. Here are some more bars, since people seem to find that more palatable. The 7900X lands middle of the pack. None of these CPUs are bad. They all provide 90 FPS to the HMD, but again, it's not worth spending $1,000 when two $300-ish CPUs from either camp, including Intel's own, can provide the same or better experience, and that's an objective measurement. As for frame times, briefly, the 7900X lands at 8.15 milliseconds average between the 8.7 millisecond average of the overclock 1700 and the 7.41 millisecond average of the 7700K. Performance is good, but it's not better than Intel's other products or AMD's other products that we've tested, and that's fine. The CPU does not have to do everything the best, and that's what we want to convey to the marketers of the world. We had this same talk with AMD's R7-1800X when they boasted all kinds of gaming things like 4K gaming, this and that. We talked about all of that then, and the point's not to pick on anyone. The point wasn't to pick on AMD then. The point is not to pick on Intel now, even though it seems to be cool, frankly. The point is that Intel, you don't have to BS people if you have a good product. It does fine at the things it does fine at, as we'll see in a moment, and as we saw in streaming a second ago. But advertising this as a VR gaming best of platform is not only wrong when your own products do better, although they are all basically the same, it's unnecessary. And it's trying to bandwagon onto a phrase, 2 letters, that Intel clearly thinks will sell more products, but all this really does is produce more marketing BS that harms the companies because it's just unnecessary. And that's really all I have to say about it, I guess. Despite the marketing, the thing is not any better at VR gaming than other CPUs we've tested, and just Intel, it's okay. You don't have to be the best at every single thing. Let's move on to more suitable tasks for this type of processor. Using GN's in-house Blender scene, including optimizations for rendering on CPUs or GPUs as appropriate, we found the 7900X effortlessly chart tops all other tested products when it's stock configuration. The 7900X completed the scene render in 21.5 minutes using its 20 threads to render 20 tiles simultaneously for the 4K scene. This is the first CPU we've tested that managed to outperform a GTX 1080 with CUDA rendering, and that's counting 256 by 256 GPU optimized tile sizes. The 7900X improves over the stock 6900K i7 CPU by nearly 8 minutes, or a 26% reduction in time required. That's massive generationally, and the more competitive pricing of Intel's modern 10-core part tells us that it was folly to expect Intel didn't have anything to compete. That said, the i9-7900 overclocked to 3.9 GHz comes closer to competing with its 28-minute render time, with the 7900X about 23% faster than the $310 part. Regardless, there's no denying Intel's lead here. For production studios that have the budget and would kill for the extra render time, this CPU is a winner at its price. Ryzen, though, should give everyone pause on pricing. If absolute top-end production isn't the objective and the buyer is more of an enthusiast or artist without a studio budget, the R7 CPUs can be overclocked to compete quite reasonably and would still be a good buy for much cheaper. They are ultimately a completely different class of hardware for this type of thing, though, particularly with X299's memory advantages over Ryzen, so this is one of those scenarios where it just depends on who has the money and who's paying for the product. Moving to Adobe Premiere, we're still slower than Mercury acceleration with CUDA, but we're seeing steady improvements overall. Using our EVGA ICX review from February to render, which includes dozens of clips in various states of post-production, we find the i9 CPU completing the software render in 54 minutes, or about 7.8% time reduction from the overclocked 6900K and 21% reduced time required from the stock 6900K. That's a decent jump, and the R7 CPUs complete the render in about 62 minutes when overclocked, leaving the 7900X with a 13% time reduction from the overclocked R7s, though with a higher price, of course. So again, trade-off of if you're a studio or an individual. That's not great value for the average end user, given the $700 price hike, but it's something that, again, a production house would consider. Then again, for this type of Premiere workload, you're really significantly better off with a GTX 1080 and CUDA anyway. We're at 20 minutes for those renders, even with an i5 CPU. Premiere just doesn't care about the CPU if it's given ample GPU to work with. Cinebench and synthetic tests will be in the article below. Moving on to some games, Total War Warhammer saw an update post-Ryzen launch that improved performance significantly on both AMD and Intel processors. Intel saw a major uptick in frame time consistency reflected in our 0.1% lows, and AMD saw a major uptick in SMT-enabled performance. CPUs with an asterisk have been retested with this update, while CPUs without an asterisk have not been retested. CPUs without the star would see an improvement of a couple percent in average FPS if retested. Stock, the i9-7900X operates at 168 FPS average, placing it behind the i5-7600K and ahead of the 6900K stock CPU, and ahead of the overclocked 1700X CPU with overclocked RAM. The stock i7-7700K CPU ranks at around 190 FPS average, where we begin bumping into GPU limitations, which illustrates why HEDT CPUs aren't really meant for gaming despite some of their advertising. Some games will use the threads, but many are still frequency intensive first. Battlefield 1 also got an update after Ryzen's launch, moving to version 1.08 and improving CPU bottom line performance. Again, the asterisks on the items mean that they have been retested. The i9-7900X runs 144 FPS average, placing it roughly tied with the $330 7700K CPU, and better yet, the $240 7600K CPU. And the R7-1700X with overclocked core and memory speeds runs 136 FPS average, marking the 7900X about 5.7% faster. Not a huge gain. We also have gaming benchmarks for Ashes and Watch Dogs 2 linked in the article below with the synthetics. Each of the conclusions for the different things was kind of self-contained in its section, but to go over it briefly here, the CPU is impressive for multi-stream output. It does really well in outputting 2 streams to YouTube and to Twitch. Ryzen does pretty well with 1 stream, to the point where you really wouldn't need a 7900X. There's not a huge difference at that point. But for 2, this is the best thing we've tested. It's just a matter of, is that a use case you will encounter? And also, is it better for you to just build a separate stream box? The reason you would do it, again, is if you want the lower frame time variance for competitive games. If you don't care about that, then this is a cheaper alternative to building 2 complete systems for the most part. For VR gaming, this is a monumental waste of money and you should buy something else. For production work like Premiere or Blender is even a better example. In Blender, there were big enough gains that the 7900X could be worthwhile to people who do Blender rendering and similar tasks professionally, and who might want to do it on the CPU rather than the GPU. Although again, if you start pumping 1080 Ti's into it, the argument gets nebulous. But for those people, this is a good product at a good price. For people who are more enthusiast artists or non-production studios, AMD is a great competitor at the price that it's at. Looking at something like a 1700 overclocked, you get really good and close performance. Premiere, the performance is closer still in our testing. You're better off with the GPU in our testing. That's not the most conclusive because we can't test for every single use case, but from what we've seen, you're better off with the GPU anyway, so it's better than the other CPUs, I guess. But that's it for this one. So plenty of other stuff in the article below. As always, you can support our testing like this and our new 4K camera, which is eating 1 GB per minute right now. If you go to patreon.com/gamersnexus, or you can buy a shirt like this one. We're restocking tri-blends this week, actually, store.gamersnexus.net, and adding that part cost me about another gigabyte. So thank you for watching. Subscribe for more. I will see you all next time.